Hey all, I hope you're all doing great. Welcome back to our series on calm cloud security, where we learn the theory and practice of cloud security without any gatekeeping. As I'm recording this video, it's almost 70 degrees out after a long winter. As soon as I'm finished with this video, I'm going to go soak up the sun. I can't wait. In our last video, we talked about what an ECR does, as well as some basic theory around containers. After all that lofty theory, I wanted to put it all into practice, and I bet you do too. In this video, we'll build a container image with Docker, test it, and push it to an ECR. Let's get started. Let's start in the AWS console. I've already authenticated and run a Terraform apply of our GitHub Terraform code, so we have an ECR. You can see the name there is our new ECR, with the resource address over on the right. Let's click into the ECR and you can see there are no images. If there were any, each one would be listed here with size, date, and some other information. Let's look at the image we'll be building. First, let's look at our Docker file. Here it is in Visual Studio Code so we can get the pretty colors. On line 1, we're grabbing the latest version of Ubuntu 20.04 from the Docker Hub online. Docker will cache this image locally, so next time we'll build, it'll be even faster. On line 4, we're copying a script called docker start into the image at the dot location, which means working directory of the container's disk. Since we didn't set a working directory with the docker command, Docker defaults to the disk's root. We'll look at that script in a second. On line 5, we're setting that script to be executable, which we need since we'll be running it as our next step. And on line 9, we set an entry point of that same bash script, which means when the container launches, this script is run. As soon as the script finishes, the container will shut down and self-destruct, which is totally normal and desirable, even though that's very different than VMs. Let's check out our entry point script. On line 1 and 2, we tell this script to run using bash and set -e, which means to exit if there's an error. On line 5, we'll check to see if my name variable is set to empty. If it is, we immediately send some custom error message and exit with an exit code of 1. In almost all software, an exit code other than 0 indicates something went wrong. If we get past that check, then on line 12 and 13, we print out a few lines of response using the myname variable. Let's not dig into that too much yet. It'll be more fun when we actually build and run this container. Speaking of that, let's do it. Let's switch to a terminal and build our Docker image. Right off, let's set some variables we'll use in our commands. First, a local Docker name. Docker calls this a repository, but this is all local, and you can use whatever name makes sense to you, even if that repository name doesn't match the ECR one we'll set up in a minute. Then let's set a Docker tag to use when we publish to our ECR. We'll use a really easy pattern, latest. Latest is also assigned to images in an ECR by default if they don't have a tag. Finally, let's actually build the container. Let's run docker build. The period means to look in the directory we're in, and the -t means a tag of the variable we set above, which is hello-name. If you get an error here about failing to connect to Docker, make sure you have the Docker service started. I did that the first time. Let's run docker image ls to look at the local Docker images, and sure enough, we see our hello-name Docker image built only a few seconds ago. Awesome! We built a Docker image. Let's test our Docker image locally. The command to run a container is intuitively docker run, and then the local image name. When we do that, we see our custom error message, reminding us we forgot to set the name variable. Remember from the entry point script? Checking to make sure we have all the variables we need to run successfully is a super common pattern, and custom error messages like we did here are a best practice. Let's set the variable and build again. We use the -e flag to set an environmental variable inside the launched container of my name equals Kyler, hello. Feel free to set this to your name and run it. We get a different message, this one telling us that our container ran properly without issues, and it even politely said hello. Pretty cool. Next up, let's push our image to the ECR. We could hard code the name of the ECR and the region name we built everything in, but we have direct access to Terraform and it can print these outputs, which is a really cool way to harvest info from Terraform. So let's do that instead. We'll use the Terraform output command to print some outputs from the configuration. Here's what that looks like. Next, we'll run the same commands but trap the response as variables so we can use that info in other commands. The way to prep our image to be pushed to a repository is to map the local image name or repository to a remote ECR name or repository with a tag. The docker tag command does the trick. It looks like this. And then run the docker image ls command to look at our images again. Now we can see what looks like a totally new image, but we didn't build a new image. Where did that come from? If you look under image ID, you can see that this is the exact same image, but using a different repository or name. Okay, let's push our image to the ECR. Okay, we tried and it failed. When we push, we get an auth denied message. So even though in this terminal session, we have a valid AWS credential in the environmental variables, our push fails. And that's because the Docker tool isn't able to use the AWS credentials to authenticate. However, clever AWS engineers are prepared for this, and you can be too. First, let's grab our region. Then we can run AWS ECR get login password to print a password out, which is kind of like STS. It's very time limited and short. And we'll use some neat bash to trap the response and pipe it right into a Docker login command. If you see login succeeded, like we do, Docker is now able to authenticate to the ECR. Awesome. Let's try that push again. Okay, something is happening. It looks like it's pushing. Let's jump ahead to when it finishes and we see a new error message, which is very helpful. It says there's an IAM resource policy on our ECR that denies us from writing to it. Let's switch to the AWS console and find that ECR again, and pull up the ECR permissions to find the resource policy. We do see a policy at the bottom that denied my user from putting an image into the ECR. Oh no. Let's fix it in the console. There's a graphical policy editor specific to just the ECR service, but I'm more comfortable editing the JSON directly. So let's hit Edit Policy JSON in the top right, find the second stanza that's blocking my user from uploading an image into this ECR, and delete it, then hit Save in the bottom right. Let's switch back to our terminal and run the same command again. This time, it'll succeed. Let's spend 1 minute looking at our ECR to verify the new image is actually there. When we click into the repository this time, we see the image we just pushed is now present. This ECR is internal, so any of our team can download it and run it themselves, and it'll work just the same as when we ran it locally. We can also see over on the right that AWS has already scanned this image, and there are some vulnerabilities within it. Select Details, and we can see a rundown of all the vulnerabilities AWS has found. We could take this information and go bug hunting, but that's beyond the scope of this video today. In this video, we covered a lot of ground. Oh my goodness. We went over common Docker and scripting patterns, built a Docker image, then tested it. Then we figured out Docker authentication into AWS ECR, and then fixed an ECR IAM resource policy issue that blocked us from uploading an image. We confirmed the image was present in the ECR, and then very briefly saw that AWS has scanned our image for vulnerabilities, and we could start remediating them if we wanted right away. Please find all the code we ran in the GitHub repo displayed on screen. I hope this has been helpful to you. You can find more of these videos at iampulse.com, and you can find me at KaiMid on Twitter if you have any feedback or questions, and I look forward to next time. Thanks all.